So in this video, we're going to go over how do we take derivatives of logarithmic functions. In particular, we're going to focus on how do we take the derivative of a natural log. Okay, so let's start off with the definition of a log function. So a log function has the following form. It's a log with a base of b of x. Okay, so I want to make this very clear. When you take a log is called an operator, meaning it does something to a number or a function. So we always have to take the log of something. So you cannot separate the x from the log or anything crazy like that. All right, so b is the base. And if you recall from our exponential video, this should look very familiar. Your base has to be positive, and your base cannot equal, that's a typo, your base cannot equal 1. Okay, your base cannot equal 1. All right, so as I said, in particular, we're going to be working with logs of base e. These logs are referred to as the natural log, and they are denoted ln. That's not a 1n, that's not an in, it's ln, natural log. Okay, so how do we take the derivative of a natural log function? Well, to me, this is one of the easier rules that we'll cover in this course. It turns out that if we have the natural log, let h of x be the natural log of some function. Well, it turns out that the derivative of that is we take the derivative of the argument. We take the derivative of f of x and we put it over the original argument. In terms of more kind of layman's terms, what you do is this means you take the derivative of the inside of your log and you put it over the original inside of the log. Okay? Pretty straightforward, okay? So when you have the natural log of something, you just take the derivative of that something and put it over what that original something was. Let's do some examples here. For example, f of x is the natural log of x squared minus 3x plus 7. So the question here becomes, what's the derivative? What's f prime of x? Well, we're going to take the derivative of that argument. And when I say argument, I'm saying, what are you taking the natural log of? Well, we're taking the natural log of x squared minus 3x plus 7. So what's that derivative? The derivative of x squared minus 3x is a 2x minus 3. And then we place it over x squared minus 3x plus 7. That's it, folks. It's the derivative of the inside over the inside. All right, let's look at a few more here. What if we have the natural log of 1x? Okay, so let's see here. So f prime of x equals, well, the derivative of a 1x is 1. And then we put over the original inside, which was an x. And there you go. The derivative is a 1 over x. Okay, where did that 1 come from? 1 is the derivative of 1x. That's where that comes from. All right. Derivative of the inside over the inside. Now this next one, we're going to have to apply something called a chain rule. So what I would recommend is if you haven't watched the chain rule video, I would say kind of skip over this problem. But once you watch the chain rule video, come back to this and maybe it'll make more sense to you. I hope it makes more sense to you. But for folks that have seen the chain rule video, we know the pattern by now. What we do is we take that outside power of 3. Okay. We leave the inside alone. We leave our natural log of x alone, but we raise that to the second power. And then now we multiply that by the derivative of the inside of that second power, meaning now I need to take the derivative of the natural log of x. And so from the previous problem, we know, hey, the derivative of the natural log of x is, well, the derivative of a 1x is 1 over x. So that's where the 1 over x factor comes from. All right, as I said, that was in the chain rule video. Watch that before you can fully understand that one. All right, so for the next few problems, we're going to have to exploit some properties of logarithms. What I mean by that is back in your algebra class, they taught you quite a few properties, but the three we're going to focus on is what's known as the power rule. And what this says, for logs at least, what this says is, let's say we want to take the log of something raised to a power p, x raised to the power p. Well, it turns out that we can rewrite this function by bringing that power out front and multiplying it by log base b of x. So notice this is not a derivative. None of these properties are derivatives. They're just ways of rewriting the logarithms so that we can take the derivatives in a more easy fashion. All right. There's something called the product rule here. It says if you have log base b of x times y, I can break that up into two separate logs as the log base of b plus the log base b of y. So if I have a log of two things multiplying each other, I can break that up into the sum of two separate logs. I can add the two separate logs. And I mean, it'll happen in your homework, but just want to be clear here. This is only true for logs of the same base. All right. And then let's say we have log base b of x divided by y. Well, now we can rewrite that as log base b of x minus log base b of y. So I'm presenting these because sometimes you have to apply these properties and then take the derivative. And here's a few examples of doing exactly that. Here we go. For example, suppose f of x is the natural log of 5x to the fourth. Okay. In fact, I'm going to do this two different ways so you can see that we can get the same answer. Okay. So the first way I want to do this is I want to apply the power rule for logarithms. Meaning what I want to do is I want to take that power of 4 there, and I'm going to bring it out front. So what I'm doing here is I'm just rewriting. So f of x is the same thing as 4 times the natural log of 5x. How is that possible? How can we do that? That's the first property that I went over, the power rule for logs. But notice this is not the derivative. This is just us rewriting it. So now how do we find the derivative? Well, f prime of x will be, okay, that 4 is a constant multiple, so it's hanging around. We've seen this in a few videos now. So it's going to be 4 times, and then what's the derivative of the natural log of 5x? Well, I have to take the derivative of 5x, which is a 5, and then I put it over that original 5x. Okay, so we have 4 times the quantity 5 over 5x. And then what else I could do is I could simplify this a little bit. Well, I have a factor of 5. Look at the parentheses. I have a factor of 5 in both the numerator and denominator. So I could divide through by 5, and so that leaves me with 1s. Leaves us with 1s. So therefore, we have 4 times, that's a horrible looking 1. So we have 4 times 1 over 1x. Okay? And so then, since this is really understood to be 4 over 1, I can go ahead and multiply this, and we end up with the final answer of 4, because you know how to multiply fractions, multiply the numerators, 4 over 1 times x, 4 over x. So our derivative is 4 over x. But what if I didn't want to use the power rule? Well, the good news is we can get the exact same answer. Okay? So I'm just going to rewrite it here. So f of x is natural log of 5x to the fourth. Let's not use a power rule. Let's just keep it like it is, and then let's go straight to the derivative. Okay, so the derivative of 5x to the fourth will be 20. 4 times 5 is 20. X to the third over 5x to the fourth. Okay? Now I want to simplify this by dividing out my like factors, my common factors, right? So 5 goes into 5 one time. 5 goes into 20 4 times, right? X cubed, I'm going to divide x cubed divided by x to the fourth. Let's see, x cubed divided by x cubed is a 1, understood 1. X to the fourth divided by x cubed leaves us with the x to the first power. Okay, so hopefully that wasn't too confusing, but if we simplify that, we get 4 times 1, 4 over 1 times x to the first, which is an x. Okay, so just in case you couldn't see that, what I did was I reduced 20x cubed over 5x to the fourth. That's what we reduced. Okay? All right, and you see that we get the exact same answer. So basically the power rule, it's up to you if you want to use it or not, but sometimes it does make your problem a little easier to understand. All right, what about this one? We've got the natural log of x squared plus 3x minus 1 over 4x minus 3. So the first thing we want to do with this is we want to rewrite this using our property of logs. So we are rewriting, we are not actually finding the derivative quite yet. And so we're going to break this up into two natural logs. It's going to be the natural log of x squared plus 3x minus 1. Subtract away, right? Because the rule that we're using now is we're going to use this division rule right here. Or excuse me. We're using this division rule here. So the log of x over y is the log of x minus the log of y. So it's the log of the top minus the log of the bottom. And what this now allows us to do is now we can find the derivative by going in and applying our natural log rule twice to each term there. Okay? So this becomes the derivative of the natural log of x squared plus 3x minus 1 is the derivative of that argument, the derivative of the inside, which is 2x plus 3, over x squared plus 3x minus 1. That's just our natural log rule. Minus, and we do it again. The derivative of a 4x minus 3 is a 4, and we divide it by the original argument, which is a 4x minus 3. And there we go, folks. That is our derivative. Okay? Now, I want to make a slight little change to this. I just thought about this. So what if they had a second power out here? What if it was a natural log of x squared plus 3x minus 1 over 4x minus 3, that quantity squared? Okay, so let me rework that. So I slightly changed the problem here. Let me show you what you would do in that case. So in that case, you would definitely do your rewrite. And what would your rewrite look like? It would look like this. I'm going to rewrite it using the power rule. So I'm going to take that 2, and I'm going to bring it out front. Let's see, plus 3x minus 1 over 4x minus 3. Okay? And then I'm going, still rewriting, now I'm going to break up that fraction just like we did earlier. But keep in mind here, this 2 is going to multiply the entire difference that we're about to make here. Meaning you're going to take the natural log of x squared plus 3x minus 1 minus the natural log of 4x minus 3. And that entire difference, that entire subtraction, is being multiplied by that factor of 2, that constant multiple of 2 that you brought out from the power. Okay? So then what does that look like? What we could do now, if you want to, you can go ahead and distribute your 2. Maybe I should do that. Let's go ahead and distribute the 2. So it's 2 natural log of x squared plus 3x minus 1 minus 2 ln of 4x minus 3. And then now we can simply take the derivative by applying our natural log rule twice. But don't forget it's going to be multiplied by 2. So it's going to be 2 times 2x plus 3, 2x plus 3, that's the derivative of x squared plus 3x minus 1, over x squared plus 3x minus 1, minus 2 times 4 over 4x minus 3. Okay? And if you want to, you could take the 2's and then distribute them up to the numerator. They're going to go up there and they're going to multiply these numerators. Okay? But that's how you handle if you had like an external power, on that there. Okay. All right. Last one. What if it's the natural log of x squared plus 1 times x cubed plus 4x minus 7? We're going to now apply this last rule, this last property here. And that says we could break that up as a sum of 2 logs. Meaning, rewriting phase here. We're just rewriting. It'll be the natural log of x squared plus 1 plus the natural log of x cubed plus 4x minus 7. Okay? Since we're multiplying, we're going to break it up. How do you know when it's plus or when it's minus? Multiplication is repeated addition, plus. Division is repeated subtraction. That's when it has the minus. All right, now we just simply apply our natural log rule twice. So what's the derivative of x squared plus 1? It is 2x, and then we put it over x squared plus 1. That's just our natural log rule. Plus, we take the derivative of x cubed plus 4x minus 7, which is a 3x squared, plus 4, and we put that over x cubed plus 4x minus 7. And there we go, folks. That is our derivative. Okay, so I know that was a bit of a longer video, but hopefully that lets you clears up the notion of how do we take a derivative of a natural log and how we can use properties to do exactly that. I'll see you guys in the next video.